Could you build a 45, 45, 90 triangle just with a piece of paper and a pair of scissors? And the answer is yes, you could. All you have to do, let me tip this camera. All you have to do is fold the paper. So you line it up like this, go exactly to that corner. And then crease the paper. And you could cut that off there with a pair of scissors and you have a 45, 45, 90. And the reason is because on a 45, 45, 90, the legs are the same length. Let me change my camera. So we know on a 45, 45, 90, we could build a 45, 45, 90 simply by getting the square and cutting it in half because the angles, those two angles are the same, those two side lengths are the same. Let's just give them a length. The easiest length I can think of is make them 1. If they were 1, how long would the hypotenuse be? Well, let's label the legs A and B. And the hypotenuse then would be C. And I hope you remember that in any right triangle, you can use the Pythagorean Theorem. A squared plus B squared equals C squared. So if we wanted to work out the length of that hypotenuse, it would be 1 squared plus 1 squared would give us C squared. So C squared equals, well, 1 squared is 1, so C squared equals 2. So C would be plus or minus the square root of 2. You think, hold on, I'm talking about the length of the sides of the triangle, so I'm not going to look at that negative square root. Okay, so that was how to build a 45, 45, 90, and you can probably remember that from geometry. And let's look at a 30, 60, 90. Now this is harder to build. I'm not going to model building one of a piece of paper and just folding it. But where you get this from would be if you had an equilateral triangle where the 3 vertices had an angle of 60 degrees, and then you cut it in half there. So if we make the shortest side is going to be opposite the 30, if we make that be of length 1, then this other half of the original equilateral triangle would also be of length 1. So the total side length would be of length 2. So this side is equilateral, so that would be of length 2, and this side would be of length 2 as well. Now, if we're looking in our 30, 60, 90 triangles, so this triangle here then, we have this one leg is of length 1, the hypotenuse is of length 2, and this side we don't know here, we can work out using the Pythagorean Theorem. A equals 1, C equals 2, B we don't know. Using A squared plus B squared equals C squared, we have 1 squared plus B squared equals 2 squared. Subtract 1 squared to that side, and we have B squared is 2 squared is 4. Subtract that 1. So B squared is 3. The side length would be the square root of 3. Okay, so do you remember doing that in geometry? It's been a while, it's probably been 2 years. Now those two triangles are going to be so important to us, I want you to actually make some notes on them. When you were in geometry, you probably put them as side lengths as a ratio to each other. Let's see. So let's make some neat notes. And this you're really going to want. You really, really need to know these well. The short leg is always going to be opposite on the 30, 60, 90. The short leg is going to be here, opposite the 30 degrees. Okay? The long leg will be opposite the 60 degrees. Now, in geometry, you probably call this variable x. I don't want you to use x, and I'll tell you why in a minute. We're going to change that in a second. The hypotenuse, remember in one we just worked out, we had 1 here, 2 here, and the square root of 3 here. And in geometry, you probably put 2x and x root 3. Well, I don't want to use x as my variable, and I'm going to tell you why in a second. Now, hypotenuse is going to be double the short leg. I'm going to not use X, I'm going to use L. You're going to see why in a second. I really, really do not want to use X as my variable. So the hypotenuse will be double the short leg, it will be 2L. And the long leg, which is opposite the 60 degrees, is also what I call the long leg, is the ugly leg. The ugly leg, because that's the one with the root 3 in it, the thing you'd want to avoid using. Okay, L root 3. Now I'm using L, and it looks weird, but I really don't want you to use X. On a 45, 45, 90, we built it just by folding, because these two legs are the same length, both legs are the same length. Again, let's just call that leg length L. They both be the same, and the hypotenuse is that times the square root of 2. Okay, so draw those really nicely, label them up clearly. You're going to refer to those a lot. Moving on, I've got a second warm-up for you. So just using these ratios, opposite the 30, we have L, the hypotenuse is double that, the long leg is opposite the 60, it's the ugly one. And this one we have L, L, L root 2. Using those ratios, answer questions 1 and 2 for me. I'm going to give you about a minute and a half, okay? Okay, so let's look at these then. This is clearly a right triangle with 45 degrees. This is 45, 45, 90. We know the legs will be the same length, and the hypotenuse opposite the 90 will be that leg length multiplied by the square root of 2. So these two sides are the same, and that gives you the length of the leg. And this would be the hypotenuse, and it would simply be that value multiplied by the square root of 2. So it's simply 6 times the square root of 2, done. That's your answer. And on question number 2, this is a 30, 60, 90. If this is 60, that's not L. This is the 30 degrees. This would be your short leg. The hypotenuse, if we needed it, would have been double that short leg. And we've been given the side length opposite the 60. So that's the long leg. That's 2, no, it's not. That's L times the square root of 3. So we've been asked to work out Y. So we just need to work out L. And how we're going to work it out is using this little equation here. If 15 equals L times the square root of 3, we're solving for L, so cancel out multiplication by division. L would be 15 divided by the square root of 3. But remember that in math, we don't like to leave irrational numbers in the denominator. We're going to rationalize that denominator by multiplying the square root of 3 by itself. Because if we get the square root of 3 squared, it's simply going to equal 3. So if we multiply that by the square root of 3, we also have to multiply the numerator by the square root of 3. That leaves us with 15 times the square root of 3 divided by 3, which simplifies to 3 is a factor of 15, 3 goes into 15 5 times. What were we solving for there? Look back up, we were solving for L, and looking over here, we can see that L was actually going to give us Y. So there's our answer. We're not going to do questions 3 and 4 there. Okay, right, so today we're doing lesson 4.1, day 1, and what we're going to do here is really, really important basics of trigonometry. This stuff is going to take you through about the next 3 to 4 months. So this page of notes here, I want you to start on a new page, and let me tell you how I want you to lay it out, because it's so important. Write the title at the top, 4.1 right triangle trig. There's going to be you'll need about 2 or 3 lines for this at the top. Make that triangle, draw it, I don't know, at least an inch by an inch, maybe an inch and a half by an inch and a half. But the main part of what we're going to be writing is this stuff down here. Leave 2 blank lines between each one. So 2 blank lines between each, and only take up half the width of the page. Because what these 3 things here, we're going to write even more on the other side of the page that relate to them. So I'll scroll down in a minute, start writing these notes. There's 2 bits of math that we can only use on in right triangles. Only for right triangles. We've just used one of them in the warm-up, and that is the Pythagorean Theorem. Well, we know that a squared plus b squared equals c squared. That only works in a right triangle. The other bit of math, you'll drag your brains back 2 years, and do you remember Sohcahtoa? Sohcahtoa. Remember that, guys? Do you remember what it tells you? What does Sohcahtoa tell you? Does anybody want to volunteer an answer? Nobody wants to talk today. Okay, right. Some little rough notes. I'm going to erase this in a minute. This isn't a big deal to me. It's not really what I want on your main notes for today. If we had that triangle that we've got drawn over there with an angle, so stands for sine, ka gives you cosine, and toa gives you tangent. And what the O, H, and A stand for is O stands for opposite, the leg that's opposite your angle. H stands for the hypotenuse, which is obviously opposite the right angle. And A stands for the leg that's next to. Another word for next to is adjacent. How you use Sohcahtoa, so tells you that sine equals the sine of an angle equals OH, that means opposite, divided by hypotenuse. We're going to use Sohcahtoa just for the next 2 minutes, and then we're not going to look at it again for months. We're not going to do trigonometry that way. Let me show you what we're going to use instead. Instead of labeling the sides opposite, adjacent, and hypotenuse, we're going to label them X, Y, and R, and that's for a very particular reason. See this cross here? This is standing in for the axes. This is an angle drawn in standard position, where this side is the positive x-axis, this side is the terminal ray for drawing it. This would be the origin, the vertex is at the origin, it's angle in standard position. And this would give us those X and Y lengths, the legs of that triangle actually give us the coordinates of an X, Y point. And the hypotenuse of the triangle, we're not going to call it H, we're going to call it R, because that would be the radius of a circle going through that point. R is the radius of a circle, with the center on the origin going through the point XY. If we go back to Pythagorean Theorem over here and replace the legs, instead with a squared and b squared, let's replace them with x squared and y squared, and the hypotenuse is R. This here is actually the equation of a circle centered on the origin. And what you're going to find out that people think of sine, cosine, and tangent relating to triangles, but then much more importantly, they actually give us, we call them circular functions, that tell us a heck of a lot about circles. So let's use this Sohcahtoa to fill these ratios in, just using X, Y, and R instead of opposite, adjacent, and hypotenuse. So don't read that, that's not part of my notes. Sine is opposite over hypotenuse, so here's my angle, the opposite is y, and opposite over hypotenuse, the hypotenuse is called r, so sine is actually going to be the ratio of y divided by r. Cosine of an angle in standard position, cosine is normally adjacent over hypotenuse, if you look up here, and adjacent over hypotenuse, adjacent to this angle is the x, and the hypotenuse is r, so cosine is x over r, and the tangent, if you look up here, there, is normally opposite over adjacent. Opposite our angle in standard position is its y coordinate, adjacent to it is its x coordinate, so the tangent of an angle in standard position is y divided by x. Okay? Now we've done that, we're going to get rid of Sohcahtoa. I'm not going to use it again. It's going to be really important that you remember sine, cosine, and tangent. They are, the sine, cosine, and tangent are functions. Their input is an angle. Their output is a ratio of two sides of a triangle. And those sides of the triangle are going to be based on x's, y's, and r's. Now, those are three trig functions, the three that you used in geometry. There's actually three more. There's actually 6 trig functions in total. The other 3 are called the reciprocal trig functions. Trig is short for trigonometric. For all of these, because they're a function, their input is an angle, their output is the ratio of two sides of a triangle. Right, reciprocal just means 1 over. The reciprocal of sine, the function is called the cosecant. Its abbreviation is CSC. So it's the function of an angle. The angle's your input. So you get cosecant theta. It is the reciprocal of sine. So it's the same as 1 over the sine of theta. And because it's the reciprocal of sine, the ratio of the two sides will just be these two written upside down. That will give you the reciprocal. So it'll be r over y. Okay. Now we're going to look at the reciprocal of cosine. It's called secant. Its abbreviation is sec. So you take the secant of an angle, the input is an angle, and the secant will be the ratio of two sides based on the reciprocal of cosine. So it's not x over r, it is r over x. And the last one, because I said there were 6 of them, is the reciprocal of tangent is called cotangent. Its abbreviation is cot. Cotangent of theta, that's the reciprocal of tangent. And its ratio is simply x over y. Now, you have to know these, you have to memorize them, and you have to know them really, really quickly. And you obviously have to get them right every time. If you mix up some of these ratios, all your answers will be wrong. So I've got a few different ways to help you memorize them. Well, first of all, I don't know cosecant, secant, and cotangent. I've been teaching this for years, 8 years now. All I remember is that cosecant is the reciprocal of sine, and secant is the reciprocal of cosine, and cotangent's obvious. So if I know these 3, I know those 3 after I've thought about them for about 2 seconds. I think whoever developed this, I think it was the ancient Assyrians about 2,000 years ago, got it wrong. I wish they had put sine with secant and cosine with cosecant, but they got it wrong. We're not going to be able to go back and change history. There must be a reason, maybe there isn't, why they go that way round. But all I remember is the reciprocal of the one that begins with S begins with C, and the reciprocal of the one that begins with C begins with S. They're the wrong way round, which kind of, they're being the wrong way round reminds me that they're upside down, okay? So once I know these three, those are easy. Now, how to remember these? Tangent is the most obvious to me. Do you see y divided by x? For many years now in math, you've been looking at the change in y divided by the change of x. That's slope. When I see tangent, I think slope. And that reminds me it's y over x and not x over y. For sine and cosine, for sine's y, that's making me think of something that's vertical. And all I can think of that's always going to give me something vertical that begins with S, I think of a screen, a giant movie screen. Now when you go to the dentist's office, sometimes there's a screen on the ceiling, but most people, if they have a screen, they mount it vertically. Sine, screen, vertical makes me think of Y. And cosines are horizontal. X gives you something horizontal, so I think of carpet. Now, I haven't met anyone yet who's carpeted the walls in their house. Most people, when they put carpet on something, they put it on a horizontal surface. So cosine carpet makes you think of X, horizontal. If you want to think of your own way of memorizing them, go for it. But you've got to be able to memorize them and know these ratios really, really quickly. Okay? Right, let's use them. So here we go. Example. Find the exact values of the 6 trigonometric functions of theta. So here's our angle. Remember, it's been drawn in standard position. So that's your x-axis. So this is your x-coordinate. The vertex is at the origin. There's your terminal ray. This is our y-coordinate. And what the x and y are giving us is the coordinates of this point here. Oh, the coordinates of the point there would be 2, 3. So the terminal ray is passing through the point 2, 3, and that would be a point on a circle of radius equals something I don't know. Okay, so I'm going to have to work out that radius because to answer those I need to know x, y, and r. So if you want to go back and write Pythagoras, a squared plus b squared equals c squared, you can, but I'm going to then go straight to, well, that gets replaced with x squared plus y squared equals r squared. That's basically the Pythagorean theorem. So we know that x is 2, so we'd have 2 squared plus y is 3, that's 3 squared, equals r squared. So that's 4 plus 9. So r is simply going to be the square root of 13. And the radius of a circle is negative, never negative. Now, for your 6 trig functions, it really, really helps if you always write them out in this order. And don't forget the fractions. So you need to leave at least 1 line, possibly 2, between each answer, so that you can draw your fractions properly. And the hint to be able to get these right and quickly is always to write out the ratios. Just quickly whiz through them, and this helps you quickly memorize the letters as well. So sine, I'm thinking screen, which makes me think vertical, so it's something to do with y over r. Cosine, I'm thinking carpet. I carpet the floor, which is horizontal, makes me think x over r. Tangent, I think slope, that's the easiest one for me, that's y over x. Okay, then the reciprocals. If you wrote the one that begins with s, the next one, the one you write opposite, begins with c. Sine goes with cosecant, and this would be the reciprocal of it, so you just write that, instead of writing y over r, you write r over y. This would be r over x, and this would be x over y. You think about go through it that way every time, it comes so fast, you can do it really easily. So now let's fill in the data. So our sine is y over r, so it's this y divided by that r. It's 3 over the square root of 13. But remember, we have to rationalize that denominator. We can't leave an irrational number in a denominator. So we're going to multiply that by root 13 over root 13. And our answer we're going to get there is 3 root 13 divided by 13. Our cosine would be the x, which is 2, divided by the square root of 13. And again, when I rationalize the denominator, that simply leaves me with, no, not 3 root 13, it'll be 2 root 13 over 3 over 13. And our tangent is just the y divided by the x, so that's just 3 over 2. Leave it like that, please. That's perfect. No decimals. I don't want to see decimals at all. No decimals in your answer. I'm not going to grade it like you've written an answer if you write decimals. Okay? No decimals, please. Your cosecant is r over y, so it'll be root 13 over 3. Your secant is your r divided by your x, so that's root 13 divided by 2. And your cotangent is the tangent upside down. It's 2 divided by 3. Okay? So all of those are the 6 trig functions of the angle theta, and we don't know how big theta is. We have no idea. Well, roughly kind of guess it's probably a bit bigger than 45 degrees, maybe about 50, but we don't care. We're not being asked what the angle is, we just were asked what the 6 trig functions were. Okay? Let's try another one. So draw that up and think for a second. See if you can fill in all those ratios. So let's look at this triangle we've got here. We've got a right triangle, put it in standard position by making that vertex be at the origin. So that means x is a side length we don't know. That 10 we've been given would be a y coordinate at this point here, on the circle, and the radius we don't know. Okay? We're going to have to work those out. Try and fill in those ratios. See if you're getting them yet. Sine is always going to be something to do with vertical, y over r. Cosine will be x over r. You're going to be able to do these really quickly soon on your own. Tangent, think slope, y over x. Now your reciprocals, cosecant is r over y, secant is r over x, and cotangent is x over y. So now we need to work out what those are. All we've got is this picture where we know one side length, but we also know this angle is 30 degrees. And this is the right triangle. So this angle up here must be 60 degrees. Because the angles in a triangle add up to 180 degrees. So we know we've been given a 30, 60, 90 triangle. And we know in a 30, 60, 90 that the shortest side is opposite the 30. And if we just writing down the ratios from that previous page, this would be the short leg. The side opposite 90 would be the hypotenuse, and that's always double the short leg. And 60 degrees would be the long leg, and that's the ugly leg. and its ratio is L√3. You're going to have to get to know these ratios really, really well and consistently. I know you might not know them so well yet today. Okay, so let's look at what we've been given. This 10 was opposite the 30, so this is the short leg. It's opposite the 30, so it's the short leg. So for this triangle we've been given, the x must be the long leg, and opposite 6, it must be opposite 60. The long leg would be L√3, and our L is 10. So this is 10√3. And our hypotenuse, our R, is double the short leg. So that's our short leg, it's double that, which would be 20. Okay, now we've got all our side lengths, we can just go fill in these ratios. So our sine of whatever, the sine of 30, we're actually working out here the sine of 30 degrees. We don't need a calculator to do it at all, we just need that triangle. Sine of 30 is the y divided by the r. It's just 10 divided by 20, which reduces to 1/2. If I wanted to find the cosine of 30 degrees, I can use that triangle and just say I need the x divided by the r. Here's the x, there's the r. So I've got 10 times the square root of 3 divided by 20. Reduce that, and divide top and bottom by 10, and you get the square root of 3/2. Okay, let's leave you for about 30 seconds, see if you can do the rest on your own. With this. So this one, you should have got tangent of y over x, you've got 10 over 10√3. That simplifies to 1/√3, multiply it by √3/√3, and you end up with square root of 3/3. That's your tangent of 30 degrees. And your reciprocal functions. This will just simply be this one flipped upside down. This will give you 2. This one gives you something disgusting. You end up with 2√3/3. And this one would give you simply √3/1. It's just √3. Let's look at that secant again. The secant of 30 degrees is your r over your x. So it's 20 over 10√3. Which leaves you with 2 over the square root of 3. And then remember what we have to do is we have to rationalize that denominator. And that's why you end up with 2√3/3. Okay? So that was that one. Let's try a more interesting example. Oh, that one's a nice one. Let's have a look at what we've got here. Sketch a triangle and find the other 5 trig functions of theta. What I would suggest to you is always write, when you've got to write out many of them, just automatically write out all 6. So you can see what's missing down here is cotangent would go in this position. Don't write 3 yet. Every single time you get one of these questions, quickly write out all your ratios. I hope you're starting to know them by now. Doesn't take long. Sines vertical, y over r. Cosines carpet, horizontal, x over r. Tangent, think slope, y over x. Then these are your reciprocals, just write them, flip them upside down. Ooh, my board's gone funny. And this would be x over y. Okay. Now you can look at what we've been given. Remember that this is a function where this is the angle is the input, And what comes out is a ratio that's two sides of a triangle. So when we've been told that the cotangent of theta equals 3, we've been given the ratio. At the moment, it doesn't look like a ratio, but make it be a ratio by putting it over 1. And now we know the ratio of two sides is telling us that x must be 3, the numerator must be 3, and the denominator must be 1. So now we can draw our triangle. Okay, remember to graph it, so draw the origin. We don't know what theta is. We don't know the angle this time, but we don't need to. We can just draw a triangle to describe it. And we know that if the x is 3, the y is 1. That's our angle. Again, we don't know what it is. I don't know what that is. It's definitely smaller than 45, otherwise the y would be 3 or bigger. Yeah? But we don't need to know what the angle is. We need to know the r. Remember, that's the radius of a point going through that point, and that point would have coordinates 3, 1. The terminal rays going through the point 3, 1. And the radius of that triangle, the r, we would calculate by doing x squared plus y squared equals r squared. So x squared, 3 squared is 9, y squared. 1 squared is 1 equals r squared. So the radius of our circle is simply the square root of 10. And remember, a radius of a circle is never going to be negative. Okay, now we have that information. Now you can go and fill in all the rest. I'll give you about 30, 40 seconds again. See if you can fill them in. And yes, I'd simplify before I rationalize. It makes life easier. Okay, so for this, the sine is the y divided by the r. So it's 1 divided by the square root of 10. And remember, we're going to rationalize that. So we've multiplied top and bottom by the square root of 10, which would give you the square root of 10 over 10. Your x is 3 over the square root of 10, which when you rationalize it will turn into 3 times the square root of 10 over 10. Your tangent is 1 over 3. Your cosecant would simply be the square root of 10 over 1, so you just write square root of 10. And your secant would be the square root of 10 divided by 3. Okay? So obviously you need to practice these to get to know these ratios really well and to practice playing around with your triangles and drawing them. So your homework tonight is simply from the textbook, so you're going to have to access that online. It's page 227, number 7, 9, 11, 17, 82, just part C. You're going to need to know this stuff. It will be on the quiz on Wednesday morning, and the stuff we did last week, where you're sketching angles, working out what quadrant they're in, converting between radians and degrees. And then the stuff from Friday, where we had linear and angular motion, and the formulas for the length of an arc and the area of an arc. Now, tomorrow, when you start the lesson, I do want you to come join me, or if you can do it in advance. You're going to have a warm-up that is due within the first 10 to 15 minutes of class. So for you guys tomorrow, I'm going to grade your warm-up at 12:15. At 12:15 p.m. tomorrow, I'm grading your warm-up. If you haven't done it by then, your grade will be 0, no late grade. Okay? And I'm going to warn you, it's got a little bit of area and arc length in it. Okay? You may work asynchronously tomorrow if you like, as long as you've got that warm-up done by 12:15. I'm going to use the fact that you've submitted your warm-up as your attendance for the day, but I'm going to be here on Zoom because you're just going to be working through a worksheet and practicing more of this. I can answer questions on your homework, okay? But that's what you're going to be doing in class tomorrow. Off you go, guys. It's the end of class now.